In this lesson, we're going to talk about how to troubleshoot memory problems. We're going to talk about problems that are caused by the memory module itself going bad. We'll also talk about common installation and configuration problems. Memory is an electronic component. Generally speaking, it doesn't degrade like a mechanical component will. However, it is possible for a memory module to become damaged. Common ways this may occur include damage from a power spike that comes from the power company into the computer, and damage from improper handling and electrostatic discharge. Memory errors are difficult to troubleshoot because they tend to be intermittent. Common symptoms could include a system lockup. A blank screen is displayed after post, the operating system won't boot all the way, or a blue screen error is displayed. Memory problems can be caused by hardware issues, but they can also be caused by software issues. For example, a poorly written application can try to use an address in RAM that has already been allocated to another running process. When the operating system detects this, it halts the entire system to prevent further data corruption. On Windows, a blue screen is displayed that describes the nature of the error. However, you may also see a blue screen displayed when a hardware memory error occurs. These errors can be difficult to diagnose. As long as the operating system doesn't try to write data to the bad memory addresses, the system will probably function normally. However, as soon as it tries to write data to a bad address, an error is generated and a blue screen is displayed. This causes the error to appear intermittently, seemingly without a cause or predictable pattern. In Windows 7 and earlier, these blue screens provided useful information that could be used to diagnose the issue. For example, you could note the memory address associated with the error. If that address changed with each blue screen, then it was likely that a poorly written application was at fault. However, if the memory address in the error was consistently the same every time you saw a blue screen, then it was possible that a memory module had gone bad. However, in Windows 8 and later, this is no longer the case. Now, only minimal information is displayed when a blue screen error occurs. If you suspect that you have a bad memory module, you need to test the system to see which one it is. There are two different ways to test memory modules. One option is to remove memory modules from the system, one at a time, until the error goes away. However, this method can take some time to yield a result. Sometimes it can take days or weeks to experience enough errors to identify exactly which module is causing the problem, especially if the problem is intermittent. A better option is to use a hardware or software memory tester to test each memory module. A hardware tester has memory slots that you plug your memory modules into. During the testing cycle, it'll check all the memory locations on the memory module and report whether or not the memory module is bad or good. There are also software memory testers that you can use. Some BIOS or UEFI chips include memory testing software you can use right from the motherboard firmware. You can also download and run software memory testers from the internet. Typically, you boot the system from an optical disk containing a minimal Linux operating system kernel along with the memory testing application and run the tests from within that environment. If a software or hardware tester identifies a bad memory module, you should replace it with a new one. Now, let's discuss memory installation problems. This category of problems is not associated with a failure of the memory module itself. Instead, these are associated with mistakes made by the hardware tech when either repairing or building a system. The first issue is ESD protection. If you're going to be working with memory modules, you need to take proper static prevention measures to avoid an electrostatic discharge that will damage the memory module. Always keep memory modules in an anti-static bag. When handling modules, be sure to use a static mat. You should ground yourself to the mat with a static wristband. One of the most common installation problems is one where the memory module isn't seated all the way in its socket on the motherboard. The memory slots used by some motherboard manufacturers are sometimes tighter than others. To prevent damage, some technicians don't push hard enough when seating a memory module. In this example, notice that this tab came up, but the other tab did not come up and click into place. This means the memory module is not seated properly. Always make sure that your modules are seated all the way down in their slots. If these two connector tabs are locked into their respective recesses in the memory module, then you know that the module is seated properly. Another problem you need to be aware of when working with memory modules involves timing mismatches. DDR memory modules have a clock built into the memory module itself, which means the memory module can only run at a specific speed. You need to make sure that the speed of the memory module is supported by the bus on the motherboard. This is less of an issue now than it used to be, as the BIOS or UEFI on most modern motherboards is able to detect the clock on the memory modules and adjust the motherboard bus speed to match. For best performance, however, you should install the fastest memory supported by their motherboard. For example, if you're working with a board that supports 1066 MHz, 1333 MHz, or 1600 MHz DDR3 memory, then you will get the best performance using 1600 MHz modules. You also need to be aware of dual, triple, and quad channel considerations, depending upon what your motherboard supports. For your system to operate in dual, triple, or quad channel mode, then you must install identical modules in the appropriate slots. If you put dissimilar modules in those memory slots, then their motherboard will operate in single channel mode, which is noticeably slower. Which slots must contain identical modules depends upon the motherboard. Check your motherboard documentation to determine the correct configuration. With most motherboards, the memory slots are color-coded to visually indicate the proper dual, triple, or quad channel configuration. Notice that these memory slots are color-coded with the same color on this motherboard, while these slots are coded with a different color. To maximize the performance of this system, you should populate each slot of the same color with identical memory modules. On some systems, you can check your BIOS or UEFI configuration to verify that all of your memory modules were detected and that the memory bus is running in dual, triple, or quad channel mode. In this lesson, we talked about how to troubleshoot memory. We first reviewed how to diagnose a memory module that has failed. We also talked about troubleshooting common memory installation problems.